Thanks a lot for attending this talk. The room is full, and frankly speaking, this is very humbling. And I'm very much excited to present some interesting stuff today. First of all, let's get something clear. So you can see on the title of the talk, macros are not going away. And let's keep this as an axiom. And now on to other stuff, now that we've clarified the most asked question of the last few days. All right, so in today's talk, we'll find answers for the following 4 questions. First of all, what's Scala Meta and how exactly it's going to replace macros, as Martin has mentioned in his keynote. Then, what can Scala Meta do? What is it good for exactly? Then we will see why you should care, because there's a lot of projects coming up virtually every week. So it's another one. So what can you do with it? How can it be useful personally to you? And finally, we will get a little sneak peek into the future of the project. And we will see what are our plans for its development. OK, so first of all, Scala Meta started as a dream. So as you can see, here's the title slide from our talk from exactly 2 years ago, also here in Berlin at Scala Days, where we introduced this idea and postulated that metaprogramming, it shouldn't be hard. And we know how to make it easy. And we didn't limit ourselves to just words, and we've started this big project. And it ended up being a really active effort, as you can see from the graph of contributions and the total number of commits. And also, we've been very, very lucky with a lot of people who are interested in helping us out. So here in the list, usually I have this list of contributors on my slides, but these days it just doesn't fit, so I had to make a screenshot from our README on GitHub. So here you can see both our colleagues from EPFL and other external folks who are helping us out. And that's really cool. I find it amazing. Thank you, everyone who helped us make it happen. Also, Scala Meta is not just a vision and some busy work. It's actually a product. So there's a jar that you can actually download from Maven. We will see the details later and put it to use. Finally, Scala Meta has official support. So it turns out that metaprogramming is really useful to Scala as the language. And Scala Meta ended up being a good fit for the standard of metaprogramming in Scala. And that's actually very, very good news. I'm glad that our ideas, they get traction. We will see exactly how Scala Meta helps metaprogramming and macros to be clearer for everyone. Now that we've established what Scala Meta is, let's see what it can be used for. Well, actually, first let's start with the status. As I mentioned before, 2 years ago, we've just started the project. And now, more than 3K commits and a bunch of milestones later, I'm really happy to announce that we're ready to release our first version. And so let's... Actually, let's make it a bit interactive. Wow, it's really small. And let's do that on the spot. So I've prepared the artifacts, and now we just need to push the button. It's a really good idea that my colleague Dennis Shabalin came up with to do this stuff during presentations. And well, let's see how it works for us. Here we go. Come on, Sonotype. Oh, well. Internet is really good. Okay. Now we just need to wait a little bit, and the thing that I promised will become a reality. So here's a bunch of releases that I mentioned before, quite a lot. And here it is. All right. So what's there? First of all, and that's the most important contribution of Scala Meta, we have a really platform-independent ASTs. This means that our abstract syntax trees, they're not built on top of Scala Reflect, that is compiler internals. They're not built on top of, for instance, IntelliJ's PSI trees. They're really designed to interoperate well with everyone. So it's a standalone standard that we will hope will get even more traction in the future. Secondly, these trees, they're designed in a way that makes sure that no syntactic details, no comments or formatting gets left out. So when you use Scala Meta, you may be sure that all the minor details about your program, they are there and you can inspect them. Nothing gets lost. And finally, we have introduced a new, quite an unexpected abstraction. We haven't even thought about that at the beginning of the project, which is called tokens. So later on, we will see how they make life easier and provide new cool capabilities. So let's just get a really, really quick tour of the functionality that's there. And you'll be able to check this out very soon. All right, so first of all, it's very easy to get started with Scala Meta. Everything that's necessary is just this blanket import Scala Meta _, and then you're ready to go. So I guess some of you here, you have worked with Scala tools in SC Global, and you've tried to make it do stuff. It's a bit more complicated, and we don't want to perpetuate this experience. So here on the second line is the example of parsing. So as you can see, if you need to parse something, for instance, a string or a file, you just call parse and tell Scala Meta what exactly you're expecting. And as a result, you get back a tree. So very simple, no ceremony. You just get straight to implementing your logic. So the interesting thing that I promised before, this high fidelity parsing, if you try to parse the string with a comment, you will see that it gets remembered in the result. So here we see a comment printed out. And to those who haven't worked with metaprogramming in Scala, who just wonder what that is and drop by at this talk, this may not seem like an achievement, but actually, this is a pretty unique feature, and this is one of the exclusive features that we provide. So how does this work? Well, it turns out that this abstraction of tokens is actually at play here. And well, tokens, they're basically elementary parts of Scala's grammar. So as you can see with the tree that we've provided here, we've associated all the, all the characters essentially that are constituted. So we can see the first token, which is empty, it's the beginning of the file. Then we have the identifier. And finally, the most important thing, there are white spaces, and there's the comment. And finally, the end of the stream token at the end. And these tokens, they're not just strings or characters. It wouldn't be very useful if they were. They're really full-fledged objects. So they have positions. You can inspect them to figure out whether you're looking at an ident or a keyword or comments. And people have already been building really cool stuff on top of this API. So a little bit later, in like 15 minutes, we will hear a first-hand report from the author of one of those tools. Also, another neat feature is support for multiple dialects of Scala. So Scala evolves, and Scala has multiple tools that use it as a configuration language. So we really ought to support everyone. As I mentioned before, one of the goals of Scala Meta is to be interoperable, to be a metaprogramming standard. And so even though SBT builds, they look like Scala, actually they're not, because, well, they allow defining methods on the top level, which is currently disallowed by the batch compiler. So in order to accommodate this interesting peculiarity, we introduced the concept of dialects. So here we use the dialect for SBT 0.13.6 to take a look at the plugins SBT build file that we have in the Scala Meta project and then parse it. So as you can see from the printout, if you try to parse this as normal Scala source, it wouldn't work. But here in Scala Meta, we have an abstraction that allows to accommodate for that. And of course, we not only support SBT and Scala 2.10 or Scala 2.12, in addition to the current version, Scala 2.11. We're keeping a close eye on Dotty, and we have a dialect that covers differences between Scala and Dotty too. Finally, I would like to conclude this really brief tour over the capability of Scala Meta by saying that quasi-calls are also cool, and we decided just to steal them from Scala Reflect. Luckily, we didn't have to steal anything because, the experience was already there, and Dennis Shabalin, the author of quasi-quotes and Scala Reflect, helped us out. But yeah, this is some cool stuff, and why not use it if it's already there and battle tested? Okay, now when we have a good idea of Scala Meta, of what Scala Meta can do, parse files with high fidelity and then allow you to take a look at the finest syntactic details, why should you care about it? So what difference does it make? Well, as a library itself, Scala Meta is useful only to a small minority of Scala programmers, to tool authors. But to our community, it's important because with Scala Meta, it's possible to write better tools. So previously, when our metaprogramming APIs were not that sophisticated, we just could not do some stuff. And with Scala Meta, a lot of new avenues become possible. And now let's see a few examples. Well, the first example, and the family of tools that's most familiar to me personally is macros. This is something that I promised to cover from the beginning of the presentation. Well, and as you all know, macros, they are dropped from Scala, right? Now, we've heard all that during the keynote the day before yesterday, and well, they're dropped for a really good reason. There's a bunch of stuff I can talk about this for hours, essentially. But if we distill this to really key points, current macros, they're hard to write, a lot of boilerplate, and the API, well, it's not for the faint-hearted. And finally, tool support, it kind of lags behind. So I mean, I shouldn't probably use the word lags behind because macros are out there for almost 5 years, but well, that's the unfortunate reality. Let's just take a quick example for those who are not quite sure what they have in mind. Well, let's write a very, very simple macro that replaces another feature that will be dropped in future versions of Scala. So let's write a macro that allows to transform a body of an object into essentially executable code that will be run by the JVM via the main method. So this is a really trivial transformation. We take whatever is inside these curly braces and put it into main. So how hard could it be? Let's take a look. Well, first of all, we have to declare a macro notation. So far, it looks more or less plausible. This macro transform method, it's kind of annoying. Why does it take any? But well, whatever. Let's roll with it. And then we get to write in macros, well, in their weird glory. First, we import this white box context. Then we import the universe. We declare an implementation. And finally, in the last several lines, we get to business. So we deconstruct the object that has been passed to us. So you can see this quasi-code, QObject $name. And then we extract the body of the code that was provided to us and wrap it in the main thing. So when I started writing this slide, I was actually thinking that the end result would be much more scary. So maybe it's not that good of an example, but if we take a closer look, then we will see that all the code that I marked with blue here, it's actually pure boilerplate. So why do we need to declare this macro transform and all those trees? I mean, what does this even mean? How wonderful would it be if we could just, omit this blue code and again get to the point without ceremonies. And another bad point about the current implementation of macros is that they don't work with tools very well. In particular, if you make a typo, for instance, here, if you call method main, I don't know, if you just miss some of the letters, this typo, it won't be detected by the IDE because typically IntelliJ IDE does not know anything about these macros. And it needs some out-of-band support from the Scala compiler to usefully report errors. And also, SBT is endangered as well. If we change the implementation of the macro, then usages of these macros, they wouldn't be recompiled. And incremental compilation is one of the cornerstones of smooth experience of Scala development. So it's really bad that these things don't work. Well, on the other hand, if we look at the bright side, macros have enabled a lot of unique idioms in Scala, in our community. And it turns out that these idioms, they're so useful that a lot of libraries, they just use them, regardless of the problems with tools or how hard it is to write macros. So you don't have to take my word for it. If you could just go to the website of Lightbend and take a look at the reactive platform they're offering, you will see that almost all libraries there, they have either used our APIs or are planning to use. So it's, or have experimented with them. So it's a fairly unique situation where we have an important technology that is not quite there. So what do we do about that? And we dropped macros, so what's going on? Well, actually, we've anticipated the situation, and a couple of years ago when the project was started, we thought real hard what to do with it. So macros actually were the main inspiration for Scala Meta. They were our answer to the question, how do we do macros without, well, going crazy, essentially? And now, since version 1.0 is finally here, it's time to unveil our plans. So macros are gone, but macros also return. And now we'll see exactly in what capacity. Well, once we got into this reflection on what's good and bad about macros, we actually figured out that macros can be further split into two different language features. So one aspect of macros is that they do metaprogramming at compile time. So this feature we called meta, and well, here goes the name Scala Meta, right? And another feature of macros is that they take some code and they inline it at the call side. So first, a metaprogram is run, it computes some results, some abstract syntax trees, and then they get introduced into the rest of the program. So here we have these two features that constitute the future of macros, inline and meta. So for details, later on, you could take a look at the pre-SIP that we've submitted for public discussion. But now I will give a real quick idea of what's going on. So let's take a look at the same macro that we've seen before, written using the API, the idioms that I was talking about. So here you can see the same code. As I promised before, all the boilerplate, it was just cut, so nowhere to be found, this separation between macro defs and macro impulse. And here we have a simple method, apply, which is defined as an inline method on a static annotation. So far, so good. And then on the right-hand side of this method, we have the meta block. So that's basically the diff between the old-style macros and the new-style macros. So as you can see, the rumors of the death of macros, they were greatly exaggerated. And now let's examine this mechanism a little bit closer. So here we go. Here we have our object, which is annotated with the main annotation. So what happens next? Well, first of all, since the method apply of the annotation is marked as inline, we just take the right-hand side of the annotation, so this entire meta block with all the quasi-quotes and stuff, and we just inline it. So the argument, of course, this is kind of pseudo-notation because it no longer uses quasi-quotes and stuff, but it more or less gives an idea of what happens here. And finally, after we have the meta block, we perform the computation, which expands into the desired result. So as you can see, it's nothing scary if you were already familiar with macros, with Scala Reflect macros before, if you have invested your time in learning how they work. Basic principles remain the same. Of course, as I promised, we're going to change API, and sometimes in a drastic manner. But that's the price for simplification and for making macros work well with other tools. So later on, we will publish our ideas of what exactly will have to be changed in macros to make them compatible with the brave new world. But for now, it's still unclear. We will get to that. And of course, when I was talking about IDE support, we really recognize the problem that macros don't work well in IntelliJ. And to that end, almost from the earliest days of macros, we've been working together with the guys from JetBrains. And some results, they're already available under interesting flags in production builds. But Scala Meta, it provides a really principled foundation to make macro support work once and forever. And now I would like to invite one of the developers of the Scala plugin team, Mikhail, to join me and give you guys a look at the results of his work. Okay. Come on in. Что будем делать?
We're taking some risks here. So there we are. That's actually the macro which Eugene showed you in the previous slides. As you can see, everything is looks normal, no red code, no unresolved symbols and whatnot. What? Can we zoom in? Control plus. I'm not really familiar with Macs. All right. Subpixel. Font size 2036. All right. Can you pop up it back? Someone is requesting bigger, someone else is saying smaller. There's a tooltip. Where the hell is it? Using toolbox. Vertically positioned mouse cursor. But it's fairly complicated. You'll be fine. No, there's a checkbox which allows you to, all right, with a scroll button. Cyclic scrolling, no, size, keywords. All right, something is really off, but I'm sure you can see at least something. Well, that's not the main point.
What I want to say is that Scala Meta is not at blame for this.
Yep. Thank you. So what we actually want to do is to see how it performs within the editor. There you go. So we're going to write a simple object. Object main and put something inside. Like hello world, hello Scala Meta. There we go. And after that, we are going to add the given annotation. Main. So as you can see, it's being marked with a special button which says expand Scala Meta macro. When you press it, it expands without need to recompile anything. So, and for example, if I change something to something else, I'm not very creative right now, unfortunately. And again, without need to recompile, it just changes everything on the fly in place. So that's the quick look into the new features that are going to be available soon. Now let's talk about what is going to be next in general. So how is it done? Firstly, as you probably know, the IntelliJ platform provides its own type checking facilities and name resolution facilities. That arises some problems, although that's the price for the fast code highlighting and refactorings. But that's not the deal. The main thing is that we take our own syntax trees, the PSI ones, program structure interface, we convert them into Scala Meta format, we resolve all the names and references, calculate types and so on, and then we feed the given trees converted ones into the macro annotation itself. So after that, we are getting the converted trees back, convert them to strings, and insert them into the editor. So that's the very basic explanation how the hell does it work? All right. So the next slide, I think it's going to be for you. Oh, no. I still have something. But that's not the end. Obviously, we're going to implement the live resolving of everything without need to expand, actually, things to, when you need the code completion, you just don't need to expand them anymore. So the upcoming semantic API will be supported. And as the long-term result will be interpreting of the Scala Meta programs, which now require actually to be compiled, but the code that uses them should not be compiled. And the next step is no compiling anything. So that's basically it.
All right,
thank
so
you.
Let's thank Mikhail again. Well, as you've seen, there's quite a lot of exciting stuff that we have prepared for you. And just to wrap up with macros and get to some other interesting things, I would like to summarize what we heard today. So first of all, macros are not going anywhere. They're just been replaced by a better system, which is based on Scala Meta. And the really cool features of new macros is that they're easy to write, as we've seen, and it's finally possible to have fully functional IDE support for macros. So what you've seen here is a prototype. It's based on Macro Paradise version 3.0. Currently it's a milestone, so which means that, well, it may or may not work, but as you've seen, works pretty stable, and we didn't even have to hard code anything. It's really, really honest implementation. We'll be looking into it in the near future, and let's get to other stuff. Well, when I was talking about macros as the interchange format for metaprogramming in the Scala ecosystem, what I really had in mind is the support for all possible environments. So we've seen how macros are supported in the standard compiler. So this Macro Paradise 3.0, it's actually a compiler plugin, just like the usual Paradise. We've seen how it works in the IntelliJ environment. So there's another case study here. Dotty Linker. You've probably heard of it yesterday during Dmitri's presentation. It was quite an awesome one, so I really recommend you to take a look at the benchmarks. The numbers look really cool. But in a nutshell, Dotty Linker is an experimental whole program optimizer for Scala. So it's based off Dotty, but it works on Scala programs, and it applies some really neat optimization techniques. One of them is auto-specialization. So for details, I refer you to the talk that Dmitry gave yesterday, but the basic point is that you no longer have to worry about boxing in most of the places. And one of the recent additions that wasn't there before is rewrite rules. So with rewrite rules, it's possible to metaprogram Dotty's linker and to tell it that it needs to change certain patterns of code to other patterns of code. And of course, when there's metaprogramming, there's also meta. So we've really looking forward to integration of linkers rewrite rules with Scala Meta metaprogramming API. So as you see here, we can take some existing class and so that uses some really slow code in idiom, and then using Dotty's linker infrastructure, we can explain how to rewrite it to be more optimal. So this is a prototype, this is early work, but we're very much looking forward to the future, to the fruits that this collaboration may bear. All right, now on to the next use case, Codacy. So Codacy is a Portuguese startup. They're doing static code analysis. They essentially have a web app that takes your GitHub or Bitbucket projects and then runs all sorts of style checks. So one of the languages that is supported by Codacy is Scala. And well, where there is a Scala and metaprogramming, probably using Scala Meta is a good idea. And now we will see how exactly this works in reality. So let's go to their website. I think I'll need to log in. Just let's give it a moment. So as you can see, here we have a list of projects. So this is Meta. it was really strange that it only gets B, so I should have really hard-coded some stuff to let it pass with an A, but hey, this is like future work. What's interesting to us here is the list of patterns that's implemented for Scala. So here in my profile, I can check out the patterns that are provided by default and then take a look at them. So as I promised, there's a bunch of languages, and one of them is Scala. So let's take a look at the particular pattern that uses Scala Meta. So here we can see what it does. So some teams, they may really prefer to convert this big ifs, else ifs, and so on and so forth into pattern match. So sometimes it really looks good. And now let's encode this check and essentially implement this small analysis with Scala Meta. If we do fork pattern in this interface, we will see a really neat web editor. So I hope everyone can see this. On the right-hand side, we have the text of the pattern. So as you can see, here we import Scala Meta on this line, and here we extend the provided interface to implement the logic. So this pattern itself is very simple. We just use a quasi-code which says, whenever we have an if, else if, then probably something bad is going on. And here's the message that we provide. And on the left-hand side, we have the test code that we can use to run this pattern and see how it works. So here on this code, it will display several messages that something is not quite right. Now let's take a look at how it works and how exactly Scala Meta helped Codacy to deliver this experience. Well, first of all, at the very early days when Scala Meta wasn't available, we didn't even have any milestone builds. Codacy used to use Scala Reflect toolboxes. So with toolboxes, it's possible to use the compiler internal API and then parse code, analyze it using the Scala-C's internal representation for programs. Well, as I mentioned before, Scala Meta really improves on that by providing very, very precise model of Scala code. And of course, this capability, it hasn't gone without being mentioned. And at some point, my student, Matthew, was starting a master thesis project. So before doing the master thesis itself at the PFL, you have to take several projects together with some of the labs. So Matthew chose us, and he was very interested in code analysis. So then, after the half a year of collaboration with Johan from Codacy, they've rolled this cool system. And this I find pretty amazing, that a student project can turn into this cool thing, this cool editor where you can use, that integrates some very, very new upcoming technology with something practical. So that's frankly what I find amazing about the PFL. And just to get a little bit into the details of how this thing works, as you've seen, code patterns, they use quasi-codes, which provide a really intuitive way of creating and taking apart Scala code. And at the moment, there's a bunch of patterns. So you can see it's more than 80 patterns, and additional stuff gets added every day. So in the future, again, it's not just a static project. I've just been in touch today with the guys from Codacy, and they told me that their plans are to work on security, on patterns that check security, and also when our additional APIs that provide name resolution and type checking are available, they will also be able to use them to have more precise rules. And finally, yesterday I got this really cool news that all those patterns, even though it's a proprietary system, all those patterns, they were open sourced. So as far as I understand, they plan to maintain it and put some of the new stuff there on the repo. And I find it pretty amazing that our collaboration resulted in some open source stuff. So now, just in the spirit of open source, and since right now we just released Scala Meta 1.0, let's come to the build of this project and let them know what happened. All right, so if we take a look. Let's check it out. Well, I guess snapshot is their version. So let me cheat a little bit. And see what actually I'm supposed to modify. It's the core build. Okay, so here we go. So here's the Scala Meta version 0.23. Now it's outdated, so we'll just change it. Hello, guys. All right, so let's submit this pull request immediately. Yay for open source. Okay, our final case study is going to be a very, very new tool that has just appeared in the recent months. It's called ScalaFmt, and it does automatic code formatting. But, well, I'll stop talking about it because the author is here, and he kindly agreed to present it today. Let's take a look.
Hello, everybody. Thank you, Eugene, for bringing me up here and talk about ScalaFmt. So ScalaFmt is a new code formatter for Scala, and I really wanted to work on ScalaFmt because I think we just have so much better things to do than talk about formatting. This is Sebastian maintaining the Scala.js compiler and commenting that one of the contributors added 2 spaces in his patch, but there should only be 1 space. So, and I think really we've seen in this conference everyone are talking about distributing their applications, getting better performance, using type classes, better design patterns, and we really want to be focusing on these things instead of white space code formatting. So I thought that, well, my personal motivation was to automate this, and I really like this tweet from Victor Klang from Leitband, because this is it should really be automated, and it is possible. So the quote says, code style should not be enforced by review, but by automate rewriting. Evolve the style using PRs against the rewriting config. So I'm hoping that will be ScalaFmt. So I want to quickly show you a demo. I'll let
Yeah, it's hard. Everyone has their own configurations, and well, but I think it's going to work.
Yeah, and just make it full screen and larger font size. Huh?
Well.
Wow. IntelliJ should have this feature. So here I have set up an integration with Vim. There's also an IntelliJ plugin and SPT plugin. And this is just an example I made myself, a classic DB object. And I usually try to fit my code in 80 characters. People have different preferences, but I usually use a split screen and an SPT on the other side. So I like to format it so that it fits in on the line. And then I pulled a few examples from code online. This one was taken from Akka, and I noticed that there were lots of long lines that couldn't fit on my presentation slides. So I run them like this, and I don't know. It's up to you which you prefer, but I personally think that this looks quite nice. This one I pulled out of Scala Z. I think it was like 150 characters long on one line. So there we go, great, and it still fits in the character limit. So like I said, you can install it in IntelliJ, and also there's an SPT plugin. Can you?
Okay.
Every time I touch his keyboard, it changes the keyboard to Russian. So you can visit the page for more information on how to use it. I'm going to quickly show how, so behind the scenes, ScalaFmt is implemented with Scala Meta and uses the examples that we were seeing earlier for parsing trees and tokens. So I'm going to quickly show really what the ideas are driving the implementation of ScalaFmt. So let's say that we have this class here, but we have some pathological like tiny character column limit, so we don't really know where it fits. And what the way ScalaFmt looks at this code really is from the token level. And Scala Meta makes it really, really easy to tokenize. And what you have is a long sequence of tokens. And what you will observe is that basically the role of the code formatter is to insert white space between like the class and the point, and the opening parentheses, etc. And these can get really long. But it's generally just, it really treats it just like this, and then it inserts anywhere. And it will not rearrange anything, and it really tries to preserve the AST, or it does preserve the AST. And then it performs a search to decide which layout is the best. And in the end, you'll have labeled some of these edges with new lines, and some of them will be labeled with spaces. And you'll have some layout like this that then can easily be constructed back into a string. And so I did this as part of my master thesis, and I managed to, with Scala Meta, to get this up and running and have a proof of concept in just like 1 or 2 weeks. And we've been really working now for a long time just on the long tail problems of trying to format basically everything we can find online. So I think without Scala Meta, it would have been impossible to really make this happen so fast. So that's really cool. I think, oh yeah, oh sorry, I forgot. Just the future plans. We currently support, there's one default style, and then there's a Scala.js style that's in progress, work in progress. Sebastian already merged one diff for Scala.js DOM using that style. So it's come quite far already. But it would be really cool to support out-of-box styles for I don't know, no one has approached me yet, but feel free to approach me if you're interested in type level style or a Spark style or a Lightbend style or your organization. I think that would be really great for people to just come in, say, we want to use this style because it looks great, and then focus on design. And then another one which I think is really would be great is if you could format only a diff. So you could just jump into a project that's not even using ScalaFmt, start hacking, adding stuff, you may be submitting a pull request, and you can, ScalaFmt will just format whatever you edited and leave everything else behind. I think this would be a great way to introduce ScalaFmt in your organization. And then we're also working on performance. So at the moment, it can still do quite well for most normal-sized files, but if you have 5,000 lines in your code, it might take a bit longer than we want. So I think that was all.
Yes, that indeed was
Thank
all.
you.
Thank you all. All right, so after this quick tour of the cool new tools that can be built on top of Scala Meta, new macros, integration with the Dotty Linker, Codacy, and finally ScalaFmt, let's see what's going to happen next. So we've seen the future, we've seen the present, and now we'll see the future. All right, so this part of the talk is going to be a little bit personal, and I was kind of surprised that it's necessary, but anyway, I think it is. Well, some of you may know that I'm a PhD student at the EPFL, and I've been there for almost 5 years. So macros and meta, they're essentially my dissertation, which I've just started writing. This has been fun too. So it's been quite cool to spend time at the EPFL, but it's time to wrap up. Otherwise, I just get kicked out by the Swiss government. That's not nice. And, well, the natural question is, so what happens after I graduate? Probably I'll go to industry and then abandon all that, and then, well, no, it'll just die. Well, don't applaud just yet, because, yeah, that's an exaggeration, of course. This all has been so important to me for quite a long time that when looking for my future job, I explicitly wanted to continue working on Meta and other open source projects. And so among the offers that I had, I chose to join Twitter this fall. And well, it was quite a ride spending all this time doing interviews and chatting with the guys and seeing how they actually could use the Scala Meta for their production. Quite amazing, the facts what I've learned. And why I'm telling you all that is that according to our arrangement with Twitter, that's really super generous of them, and that's why I'm so excited about joining them this fall. Half of the time I'll be just doing whatever I want, which means this stuff that I've just shown, so it's not gonna die, it's still gonna continue, and then the rest of the time we will be making Scala tooling and Twitter better. Also really looking forward to that because they have a lot of code and projects at scale. They present unique challenges, so that'll be fun. Speaking of Scala Meta getting less personal after, well, reassuring you that this thing is not going to die, and this is not just, the future work section in an academic paper, the stuff that no one had time to do and no one will. So actually what we do plan to do is, the big next step is the semantic API. So with Scala Meta, it will be possible to do type checking, name resolution, whatever you expect of the metaprogramming framework. So essentially, we plan to achieve feature parity with Scala Reflect to make Scala Meta do reasonable stuff. Of course, calling into compiler internals, casting to Scala tools and a C global, this is out of the question. No more, that was a mistake. And then, after we have the semantic API in place, we'll be able to roll the fully featured new style macros that are based on inline and meta blocks. Also, since I mentioned being platform independent as one of the essential goals, we do plan to support other execution environments. At the moment, we run on 2.11, not just 2.11.8, just all kinds of 2.11. But later on, we want to explore other avenues. This is pretty mandatory. One interesting idea was to do a ScalaJS port, and well, there's work ongoing about that. So you can join our Gitter and see how it goes. Maybe help us out. So this is very exciting to me personally. Well, finally, let's just summarize what we have heard today and what I think is worth looking forward to in the future. Well, first of all, I said that a few times already, but macros are not going away. We'll be making them better, but the main idea of compile time function execution is going to remain there. I'm graduating soon, real soon. I have the defense in 3.5 months. But later on, this whole show will continue, and I'm still going to be leading the effort, so nothing changes, essentially. Finally, speaking of Scala Meta, as we've seen, the project is officially endorsed. The project is funded, and we've just released our first really stable version. There's already folks at JetBrains, Codacy, and well, Olaf with ScalaFmt, which are building cool stuff with Scala Meta, thanks to its unique features. And well, we're looking forward to welcoming more guys into our community. Join us, and thanks for attention.